or less optically dense, even if correct. So don't bother. But on the other hand, if my light is going this way, then yes, what will happen to the light? It will refract like that. Okay? Refraction. But what happens if I shoot the light from here? Sorry, I think I used black. If I shoot the light like this, how will it reflect? Then it will go this way. Then if I go even further, I have this angle. What will happen? My light at some point is going to just go along the surface, no? Alright. So in this case, this is my critical angle. When my light actually goes along the surface, at this angle, my refracted light, these three are all refracted light, by the way. But for this case, the reflected light actually moves along the surface, no? Okay. But let's go a bit even further. What if I have this case? What will happen? Yeah, you just bounce backwards, no? And this is called internal reflection. So, yeah, just understand this concept. Okay. And
they give you the distance and time. So my favorite
it's represented by C.
800 kilometer in 5 years. Okay. 800 kilometers for 5.5 hours.
Whereas this angle is your incident angle. Or the last ray of light. So this is the incident angle. And you notice for internal reflection to occur, incidence angle must be greater than critical angle. Okay, whereas for my blue ray, my incident angle equals to critical angle. So this is my incident angle. And it equals exactly to the critical angle, so the light will just move along the surface.
I got the same distance.
And of course, for my last two cases, for these two cases, my incident angle is less than critical angle. So therefore,
that will stay the same. Then they change their speed. So now we want to find their new time.
For these two cases, the purple and the black, there is no internal reflection. You only have normal reflection. Okay.
So you want to find the
Let me drink some water.
your distance is the same for Wait, sorry. Five speed music. Five. 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 You take the new speed, right? 120. You give me 5 hours. 5 hours, yeah, that's why I'm saying 5. Oh, finally, I don't for something again. I need to drink water. Wait. You don't really like close my eyes. I don't need to do anything. We all need exercise. Either way. You all want a 5-minute break before we continue. Thank you. Yes. Okay, I need to focus on what you need to focus on.
Okay. And the favorite example is your what they call optical fiber. Where can you find optical fiber? Optical fiber, where can you find them? Wire. What kind of wire? Yeah, right. Angel, where can you find optical fiber? Okay, go back and check. Broadband fiber. I bet your house is connected to broadband. I hope you are not using your data 4G or 5G. The Wi-Fi in your house is connected by broadband. It should be somewhere near to your main door. Okay, it's just a very tiny wire, usually yellow. Inside is your optical fiber. How does it look like? Something like this. There is a yellow casing. This is typically rubber. That is the outer casing. And within your fiber will be your glass. All right. So inside there we can entirely fit. It's just a glass fiber. But that also means it's very fragile. Trust me, if you try to bend it, it's going to break. All right. So yeah, don't break it. It's quite expensive. But one question, what do
Maybe
you,
it's just like the.
do you want the glass to have a small critical angle or large critical angle? Think carefully. Okay, let me phrase it for you. You want internal reflection to occur. You want internal reflection to occur in the glass. So do you prefer to have a small critical angle or large critical angle? Yes. Okay, you prefer a material with small critical angle. So therefore, it's easy for internal reflection to occur. Actually, the idea is quite straightforward, but you just have to understand it. So essentially, you have your light. Oh, by the way, what's the purpose of light? By the way, inside this optical fiber, what's the purpose of light? Why do you want to shine light into the optical fibers? Let's say for broadband. All right, basically, your broadband, it conveys light signals. So instead of electrical signals, it carries light signals. So it doesn't carry electricity, it carries light. which have quite a few advantages compared to electrical signals, but we won't go into that. All right, so basically your light goes here. This is your light. Now, because this incident angle is greater than critical angle, so let me this is the incident angle. So of course it's greater than critical angle already because your critical angle is more, so it will just bounce straight. This is the second critical angle, which is also second incident angle, which is also greater than critical angle, so it reflects again. And it just continues. Yep. So basically, there is no very little absorption or very little loss of the light. The light just gets reflected on and on and on and on and on. Yeah, that's the theory. Anything besides that? Okay, fine. Right, another thing? No, serious. Okay. So, yeah, any other thing I need to tell you? But actually, there's one question that you all didn't ask. This is glass is a medium, but what is the other medium? Remember, for internal reflection to occur by right, you need two media, right? What is the other medium? Rubber. Not exactly, because rubber is not exactly a transparent medium. So actually, I didn't draw perfectly clear, but there is actually airspace. So in other words, over here, okay, let me use a different color. In between here, there is some airspace. It's not perfectly enclosed between the glass and the rubber. You can think of it as an airspace. So the other medium is actually air.
For example,
Because remember the second condition, you need the light to move from glass to air, something denser to less dense. So air is the second medium. Yep. Questions, anyone? Angel, anything you want to ask? No. Other topics? Oh, perfect. Okay, good. Hey, you? Nothing. Then I ask you a separation technique. Separation techniques, have you done it? No. Yes. Oh, maybe I ask Jingxuan as well. Jingxuan, anything to ask? Other topics? Oh, no. Okay. Okay, let's go through a quick one. Oh, by the way, Jingxuan, I can't remember. Jingxuan, have you done separation techniques? You have a okay, great. Okay, come, each of you, give me one.
It's great. I do it must be.
May you give me one separation from that?
I'm not being. I can't be convert.
Okay.
Definitely becomes. Like,
Angel.
and I didn't even have anything on it.
Huh? Okay, good. Okay. Paper, tomato, gram. But let's call it chromatography because chromatogram is what you see, the output, the product. But the process or the technique is called chromatography. I mean, try to be grammatically correct. Chromatography. Good. Distillation. May, does your school differentiate two types of distillation? Yes. Oh, okay. What are the two types, May? Which one? Okay, Jingxuan, take note. There are actually two types. Angel, anything else? No. Okay. Anything else, May? Jingxuan, anything else? Jingxuan? Nothing again. Angel, anything else? You mentioned about separation funnel. Separation funnel. Okay.
And I did
May, anything else? No. Well, some schools, in fact, most schools have mentioned this, even though it's hardly tested. And of course, some schools mention this as well. May, does your school mention reverse osmosis? Yes, sir. Okay, yeah, those are the basic ones. Okay, the difficult part. That was the simple part. Okay, just now May started off with filtration. Come.
Strides at a speed of 80 kilometer per hour. If the cyclist increases the speed to 24 kilometer per hour, By how much percentage does the travel time increase when covering the distance?
Tell me, filtration separates what from what? Oh, okay. Liquid from solid. Of course, can be vice versa as well, or solid from liquid. That's what you want, whether you want the solid or you want the liquid. Now, when you run the filtration process, what is this liquid called? The liquid that goes through the filter is called Angel. What's the solid called? That is retained by the filter. I'll give you a clue. It starts with R.
Travels at me. What is my opinion?
Can, right. So this is your filter funnel. Now I think it depends on your school. Some schools are very particular, no? They want you to write what the operators needed. So you have to write both filter funnel and the filter paper. It depends on your school. Some schools need you to write both as the operators. Now, I hope you realize basically the residue is here. All right, it's retained by the filter. And of course, the filtrate goes through. All right, basic concepts, but you need to get this correct. Or else, yeah, you have a lot of consequences in upper side. Oh. Next one, crystallization. Angel, you were the one who said this. What does it separate? Crystallization separates crystal from liquid. Okay, almost right. But let's be a bit more specific. It basically separates a dissolved solid. Notice I use the word dissolve from its solution. That means this solid must at first be in solution form. So of course, examples will be sugar, correct, table salt. So you want the salts or you want the sugar, therefore you perform crystallization. And you do not want the liquid, correct? You do not want the solvent. Okay, I just want the dissolved solid. I do not want the solvent. Paper to chromatography, Jingxuan, what does it separate? Always in see still there. Okay, Jingxuan, what does paper chromatography separate? Not sure. The colors in the object. Okay, at least you get the colors right. Now, this is important because I guarantee it's going to come out. Separates dyes from a mixture.
Oh God.
Oh, of course, dyes are colors. There are various colors. Right, so the dyes are mixed together. The dyes are not dissolved. But what else do you need for paper chromatography to work? You need sorry. A paper. Okay, right. You also need something, right? What else? You need substance. What substance is that? Oh, hold on. Somehow my thing hang over here. I can't activate this. Okay, never mind. You also need a solvent. Okay? For paper chromatography to work, you want a solvent that is able to dissolve all the dyes, theoretically. Let me restart this. Oh, no, this thing just got hang. I can't activate it.
My brain definitely not dying.
Okay, meanwhile, while waiting for it, how about distillation? What does it separate? Simple or fractional? Simple. Fractional? Liquids and okay, but there's a bit of a misunderstanding. Let's clarify that. Okay, first thing, let's just write this in. Basically, you need a solvent. Okay, suitable solvent. Dissolve the dyes.
If I write it and make 5 over 3 divided by 3 over 3. What? Let me rewrite.
Okay, let's go to your distillation. Simple. All right, come. Simple separates.
These. And then we 5 over 3 divided by 3.
Solvent from
Now I get 25.
a solution.
I think I'm gonna feel my nuts.
Okay, so be very conscious you want the solvent. That means the example is my solvent is water. Okay, example, you want water and the solution is seawater. Right, so basically you boil your seawater, you collect the vapor, condense the vapor, and that gives you pure water. Can me? Right, so you want the solvent, you do not want the salt, you do not want all the other contents in the seawater, you just want the pure water.
Yeah.
But how about fractional? Well, just now you were almost correct. Oh, okay, like mostly correct. Separates miscible liquids. Of different boiling points. Okay, the words miscible are important. May you tell me what is meant by miscible? Empty. Yep. All right. Basically, the word miscible means mix. So they are mixable. Example? Angel, what examples of miscible liquids? What two liquids can be mixed together? Okay, let's have water. Water and what? What can mix with water? Your model answered, or your model example is alcohol. Okay, and in case you ask water boiling point, Angel? Yes. Name alcohol? Don't know. 78. So yeah, there's a significant difference, 22 degrees Celsius. Right, so if you perform fractional distillation, I don't think I want to draw it out. Oh, maybe I do. So you have them here. Right, you boil them. Then you have something on top. What is that something on top here? Okay, what is this thing? Fractionating column. What is inside the column, eh? Do you know? Spiral. Okay, that's one possibility. Right, there are other possibilities, but okay, I will go with that. So over at the top, something comes out, the vapor comes out, and then you have something else here. This thingy here. Yep, what is this thingy here? Yep. Okay, that's the condenser. First is to condense the vapor into liquid.
Oh, bro, are you okay? You not bro, you just
All right, so that means a liquid will come out here. Remember, it condenses the vapor into liquid. What is the name of this liquid that comes out here? There's a name for it. It's called a distillate. Come, Angel. In this case, I am distilling alcohol and water. Which substance will come out first? Good. Why? Yes, simple as that. Okay, so I don't think I need to write that down. Yes, alcohol will come up first because it has the lower boiling point. Okay, evaporation to dryness. What does it separate? Okay, just now you was the one who said this, right? Okay, solid. Okay. Oh yeah, yeah, pretty right, but actually it's the same as here. It's the same answer as crystallization. Just that I haven't added my accept inside. Okay, can exactly the same. Accept for what? Now, when do you use crystallization and when do you use evaporation for dryness? You notice both are the same thing. I mean, the purpose is the same, but why do they have two different methods? Okay, the key is this. If you can remember, for evaporation to dryness, the solid must be stable to heat.
Working. Yeah, I got my working. I forgot the word. Oh, I'm sorry.
Okay, remember you're heating it, no? It's going to take out a lot of heat, so it better be stable. It doesn't decompose when you heat it. That is the key. When to use crystallization and when to use evaporation. Therefore, by right, you can't do it for sugar. Okay, you can't evaporate sugar solution to dryness. The sugar will undergo chemical reaction. You know the reaction agent? You heat sugar, what will happen? Yeah, something else. It will turn black. It will turn black. And they called it
What was question today now?
okay, just extra, no need to know if you don't want to. Alright, so basically, remember this sugar, if you heat it, it will caramelize.
Answer is me. What's your unit? Yeah, you say it like you say that again. You know I want you to say that. Because he said it.
Okay, so let me just go back here. Crystallization typically is performed if the solid or the salt is sensitive to heating.
You my dad. So firstly, you can find the total distance, right? For the first 2 hours is 40 kilometers. So the second one, they
Okay, just keep that in mind.
the total trip is 4 hours, so it's
Like,
like
of course.
must be 2 hours. So 30 times 2 is like 60 kilometers. So total distance is 100 kilometers. Okay. Now we got the time. They tell us the whole trip took 4 hours. We can find the average speed.
Okay, almost finishing. Okay. Oh, by the way, May, what apparatus do you need for evaporation to dryness? Bunsen burner, what else? Tripod fan, good. Anything else? How do you hold the solution? Okay. Well, since we have the word evaporation there, you are going to need your evaporating dish. Okay, next one, separation funnel. Angel, what the separation funnel separate? Excellent. Okay. Now, remember just now, look at the distillation. Separates miscible liquids, but for separation funnel, it separates immiscible liquids. Examples, India? Yes, good. Oil and water. And it looks like this.
Oh, if you remember this, you have to allow done to times time. Speed is equal to time, time is equal to speed. Ouch. And every speed is total distance over total time. I think for you guys, the most you all need to remember is the conversion. The conversion you all need to know.
Okay.
Remember,
Yes,
you guys can do speed, but
alright, this is a separation funnel. You put your mixture inside mixture, not solution. So the oil is on top, water below. This valve is closed. So if you open this valve, the water will flow down. And then you release until the boundary, and then you stop this. So all the water has come out. What is remaining is the oil. It's very simple to use. Okay, magnetic separation, I don't think I need to mention. Basically, it separates magnetic materials. Sublimation. May, what is sublimation? Agent sublimation. I don't know. Can't remember. Solid becomes a gas. Okay, this is sublimation. And only certain substances can do this, not all. Examples, try to remember if you can. Carbon dioxide. I hope you know CO2 can become a solid. And of course, in this case, it's called dry ice. Dry ice means solid CO2. So if you leave it in the air for long, it just turns into gas by itself. Now, the other important example is iodine. All right, solid iodine. You just heat it up, it turns into vapor. And a few more examples, but I don't think you know those substances at this point of time, so I'll skip them. Just remember this two for now. All right, so for example, quick one before I finish off. Imagine I have this container here, solid now. So you have iodine, and let's say sand. All right, so actually the easy way is simply to heat it up now. All the iodine is simply vaporize, even though it's in solid form. So what is left will be your sand. Okay, just keep that in mind. last one. Tell me, what does it separate? Okay, basically it separates a solvent from a solution. It is something like simple distillation. So same thing. The example, the best example, classic example, you want water to be separated from seawater. Okay, just one last thing. Actually, think of reverse osmosis as a filter, a very fine filter. You can't even see the holes. So if I have this filter, all right, they don't call it filter, they call it membrane. And then if you have seawater here, and then you apply pressure on it, push it down into the membrane. Pressure. Okay, guess what? Only water molecules are small enough to go through. And all the salt will remain behind. Okay, remember the salt are dissolved, no? Imagine they are so tiny, but yet they can get retained. Okay, so for the membrane, you can't see the holes at all. They are invisible to you. But somehow, the salt cannot pass through. Only water molecules are small enough to pass through. It goes without saying, you need a lot of pressure, a lot. Okay, questions? No? Right, so yeah, then in that case, we shall end today. Jingquan, any questions from you? No? Okay, yep, then that's all for today. All right, bye, Jingquan.